All right, so exclude when the denominator is 0, that means it's undefined, and exclude when the radical of an even index, if this number right here is even, or if there's no number, it means there's a 2 right there, an understood 2. If this is negative, we are going to exclude that, okay? Exclude when the denominator is 0, or the radical of an index is negative, is an easier way to say all of that. Right? When they ask you to find the domain, they're just saying, what is it not? For B, because we have x squared minus 25, if we put a -5 in, we get 25. 25 minus 25 is 0. So this would make our denominator 0. And then a +5 squared would equal 25. 25 minus 25 is 0. Okay, so we're excluding numbers that would make a denominator 0 or put a negative term under an even radical. Let's go on to letter C. Letter C, we don't have any fractions, but we do have a radical, right? All right, so when we had a denominator, what we did was we took only the denominator and we set it equal to 0 and we solved for x. We got x is -5 or x is 5. Here, we cannot have this part of our equation be negative. So what's a way to say that? If it cannot be negative, that means it must be greater than or equal to 0. Okay, and it says it right here. The radical of an even index must be greater than or equal to 0. So it can be included if the radical is greater than or equal to 0, right? And what's the radical in this case? It's 5 minus 5t. Is that okay? 5 minus 5t has to be greater than or equal to 0 because if it's a negative number, then that is an unreal number and we can't work with it. Okay, so whatever your radical is, if that's an even number right here, your index, or if it's a 2, you're going to take everything that's under that radical, put it as greater than or equal to 0. Good. Then you just solve for your variable. What can t not be in this situation? Good. So we're just solving for t. We get -5t greater than or equal to 0 minus 5 is a -5. Good. Divide by -5. And we get t, -5 divided by -5 is a +1. But remember, because we divided by the negative, we have to switch that sign. You know, that's calling on information from a long time ago. So basically, our domain for the letter C, because it's a radical, is that our t, usually our x, but our t has to be less than or equal to number 1. Good. So one way to write that is, the domain is t such that t is less than or equal to 1, close the brackets, or remember we talked about interval notation, it's less than or equal to 1. So less than means -infinity, right? It begins at -infinity and it goes to 1. It includes 1 because of that equal sign. So it's -infinity to 1 with a bracket for the letter C. And our last one, D, has f of x is the square root of 2x plus 6 over x minus 2. So now this includes both, that includes both a denominator, a variable in our denominator, and it includes a radical, right? So Here, we cannot have a negative under the radical, and here we cannot have any values for which the denominator is equal to 0. Right? So we're just going to, for the radical, we're going to do the same thing as C because C had a radical. We're going to take what's under the radical, set it to greater than or equal to 0. So that was 2x plus 6 greater than or equal to 0. Solve for x. So I'll subtract 6. 2x greater than or equal to negative 6. Divide by 2. It's positive 2, so I don't need to change anything. X is greater than or equal to negative 3. Good. And we need to account for this. The way we accounted for this over here was we took the denominator and set it equal to 0. So x minus 2 equals 0. So it means when x is 2, our denominator is 0. That's a problem, right? So we know that x cannot be 2 and x is greater than or equal to negative 3. How would I write that as set notation? So we would say the domain is x such that x is greater than or equal to negative 3 and x cannot be 2. In interval notation, we're going to say from negative 3 and including it because of that equal sign. So from negative 3 to positive infinity, right? But excluding the number 2. So from negative 3 to 2 and 2 to positive infinity. So there's 2 different ways to write that answer that we got. Good. When they ask for the domain, they're just asking for x, and they're asking for you to take anything under an even radical, set it greater than or equal to 0, and anything that's in the denominator of a fraction and set it equal to 0 and eliminate that answer. So you're eliminating this one and you're putting this boundary on it. Example 8. So we already changed the x's and the f of x's in a previous example. Now we're combining 2. All right. So there are 2 functions. F of x is equal to x minus 1 and g of x is equal to 2x squared. So how do we find the domain of x plus g of x? Just means you take x minus 1 and 2x squared. Good. All right, b, we're just subtracting them now. F minus g of x is x minus 1 minus 2x squared. So now you have negative 2x squared plus x minus 1. If we're multiplying them, x minus 1 times 2x squared. So I'm just going to take that 2x squared and distribute it. You get 2x cubed minus 2x squared. And finally, f divided by g of x is x minus 1 divided by 2x squared. Good. However, you also want to eliminate from the domain any number that gives 0 as your denominator. Okay, so if they've asked you to turn it into a fraction, it wasn't previously a fraction, you're also going to need to give the domain of it. So remember, if this is equal to 0, we need to eliminate it. 2x squared equals 0. Divide by 2. X squared equals 0. Square root of x squared, the square root of 0, plus or minus. So we have x is equal to plus or minus the square root of 0, the square root of 0 is 0. So x equals 0 makes this 0, of course. So x cannot be 0. So your answer is this with the domain of x such that x cannot be 0. Or negative infinity to 0, 0 to infinity. And that is what we did not finish about 3.1. Email me with any questions you have as they ask for the domain, for the range. Is it a function? Does it define y as a function of x? And what values you need to exclude from the domain, because sometimes it's just language that makes it sound more confusing than it is, or you just need more practice, which is fine. All right, so we're moving on to the graph of a function. I again encourage you anytime you see graphs or they're asking about graphs to put your graph into Desmos if they're giving you any kind of equation or any points. Just put them into Desmos, see what happens, okay? So when you have the graph of a function, a good way to determine if something is a function is if it passes the vertical line test. The XY plane just means this is X, this is Y, this is the XY plane. A graph in the XY plane is the graph of a function if, with 2 F's, means if and only if. Every vertical line that intersects the graph is intersecting the graph in at most one point. Make sure you're only using completely vertical lines. Just start drawing vertical lines on your graph, right? If there is a place where your vertical line touches your equation, the graph of your equation, in more than one place, that means that you have 2 X values with different Y values, right? If we just thought about it. Let's make up a point. This will be X is 0, Y is 2, right? Here we have X is -1, Y is 2, X is -1, Y is -4 maybe, right? It's very evident that for the X value of -1, you're going to have 2 Y values. Here you're just having -2, 0 maybe. Here we have -3, 2, -3, -2. So the vertical line test works because each X can only have one Y, right? Each X value has a unique So it will not repeat y value, or sorry, not it will not repeat, but it will not generate a new y. Okay. At most 1 point means 0 points is fine. Here it doesn't cross at all, that's okay. Right? But if there's anywhere that it intersects in more than 1 point, that is not a function. So let's talk about it. Is this a function? Yes. There is no point on the graph at which you will cross the graph more than once with a vertical line. This one's not a function. I can see 2 different values for this x. I can see 2 different values for this x. I can see 2 different values for this x. Here, I'm not crossing the line at all, but it doesn't matter. The very tip, you might cross it at only 1 point, but that doesn't matter. You're looking at the whole graph, okay? If there's anywhere where it doubles back on itself, it's not a function. This one's okay, this one's a function. And this one is not a function. Again, it doesn't matter if some places it does only cross it once, some places it doesn't cross it at all. If there's anywhere it crosses twice, it is not a function. Remember that. You can have mappings. Right? So they might be mappings. The pink maps to 5, the green maps to 4, the orange maps to 3. That would be a function. Where these are your x's, these are your y's. Here, because you have a 1 as the x value with the different y's, this is not a function. You want each x to only map to 1 y. All right, this is a long example, but this is going to cover domain, finding values of x, or finding values of y when you're given an x, and finding intersections of the graph and finding intercepts. Yeah, this is going to cover everything. Okay. Remember, before we start with this graph, that our domain is our input. Our domain is our x value. Our domain is our independent variable. And our range is y. Ooh, or you can call it f of x. Very important to remember that. It's your y value. It's your f of x. It's your dependent. So you're putting in the x and you're getting out the y. Output. So that's how we're starting. All right. It says example 2, let f be the function whose graph is shown. They don't tell us what the equation is. We just look at the graph and we find all of these answers from the graph, okay? Notice on this graph that there are no arrows. So the graph begins here, goes like this, and ends here. What a graph is a line of infinitely many points, okay? So even though it has a beginning and an end, there are infinitely many numbers that are on this graph because of how far you can zoom in, okay? You can zoom in forever. If your domain is all of your x values, that means that all of this, right? All along your x-axis is your domain. So you can kind of decide right now, what is my domain? My domain is between x equals 0 and x equals 2 pi, right? It begins at x equals 0, it ends at x equals 2 pi. Good. You can also think of, what is my range? My range is going to be my y value. So up and down. What's my lowest range? My lowest range is going to be y is -2. My highest range is going to be y is 2. Right? Okay, so that's the graph I'm looking at. That's the domain I'm working with. That's the range I'm working with. Part A says, what are f of 0, f of pi over 4, and f of 7 pi over 4? Remember, we don't have a calculator. We don't have an equation. All we have is a graph. So f of 0, this is all f of x, right? So f of 0 means where x is 0. 0, where x equals pi over 4, and where x equals 7 pi over 4. So f of 0 means that when x is 0, what is y? It's this point right here. Y is 0, so it is the point 0, 0. F of pi over 4 is, now you just find where f equals pi over, or sorry, not f, x equals pi over 4, because all of this is f of x. F of pi over 4 is going to be 1 point. It's the point pi over 4 comma 2. So when x is pi over 4, y is the number 2, and it is shown on the graph at the point pi over 4 comma +2. Okay. Finally, they asked for f of 7 pi over 4. You just find 7 pi over 4 as your x on your graph. It's down here. Your y value is -2, so that's the point 7 pi over 4 -2. Good. So what are f of 0, f of pi over 4, and f of 7 pi over 4? You're just finding the y values of each of those x's. Good. B asks, what is the domain of f? So we did domain in 3.1, which was today. The domain is, we've already figured it out, right? It's everything on the x-axis. The graph on the x-axis starts at 0 and ends at 2 pi. So we're just going to say that the domain is between and including 0 up into 2 pi. So you could say x is greater than or equal to 0, x is less than or equal to 2 pi. Because the domain is just asking for the x values. C is then going to ask for our range. What is the range of f? Again, we decided that it goes from +2 to -2. You always want to start with the smaller number. So my range is between -2 and 2. We're going to use brackets, but because we can see that it touches -2 and it touches +2. Okay. Another way to write it is y such that y is between -2 and +2. D then asks us to list all the intercepts of f of x. All the intercepts doesn't specify whether it's the y-intercepts or the x-intercepts, so you want to choose every point, every place it crosses. Every place f of x crosses the x-axis or y-axis. Right? So let's look at it. And they labeled them all for us. So we just list these. We have the point 0, 0. We have the point pi over 2, 0. We have the point pi 0. We have the point 3 pi over 2, 0. And 2 pi 0. Those are my intercepts. If it crossed on the y as well, we would include those, but it only crosses the y here at 0, 0. Those are all my points of intercept. Letter E asks, how many times does the line y equals -1 intersect the graph? So when we were finding, let's just go back to D, when we were finding the intercepts, we were talking about how many times the graph is intersected by the line y equals 0, right? The x-intercept is y equals 0. One moment. All right, so this was y equals 0, right? We said our range is between y equals 2 and y equals -2 because this is the line. If I can get it nice and straight. This is the line y equals -2. Here's the line y equals +2. So here's +2, here's 0, here's -2. Right? It crosses y equals 0 at 1, 2, 3, 4, 5 times. It crosses y equals -2 twice, y equals +2 twice. Now they're asking how many times does the line y equals -1 intersect the graph? So what we're going to do here is we're just going to make a line or imagine a line if you're looking at a computer. And that's easier. You're going to make or imagine a line at y equals -1. If you were to make a line at y equals +1, it would just be that line. Good. How many times does the line cross the graph? 1, 2, 3, 4 times. It doesn't ask what those points are. It doesn't ask where, it just says how many times. That's 4 times. Good. All right. Here, we looked at the x value of 0 and said, what is our y? The x value of pi over 4. What is our y? The x value of 7 pi over 4. What is our y? Here, what is x when y is -2 is what this is asking. What is x when y equals -2? Y equals -2 is this line. So for what values of x? F of x equals -2 at 3 pi over 4 -2. And 7 pi over 4 -2. Again, we're just taking all this information from the graph. Okay. But they did not ask for points, they just asked for the x values. So f of x equals -2. Here we wrote it as f of 0 equals 0, f of pi over 4 equals 2. So here we're going to write it as f of 3 pi over 4 equals -2. And f of 7 pi over 4 equals -2. Or you could just say x equals 3 pi over 4 and x equals 7 pi over 4. So here are the points. Here's the equation, and here's just the x value that they asked for. Our final question is, for what value of x is f of x less than 0? That's what G asks. For what value of f of x is f of x, or no, sorry, greater than 0? F of x is greater than 0 is the same as saying y is greater than 0. Okay, and we've been looking at y a lot. Here's -2, -1, 0, +2. Where is y greater than 0? We're going to take every point where y is above 0. It's both of these waves right here. Okay, how would we write that? Where does the graph begin and end on the x-axis? We would say f of x is greater than 0 at the points between, right? We're saying on the x-axis, this one is between 0 on the x-axis and pi over 2 on the x-axis. Let me see, between 0, I don't mean to write the parentheses, I just want to write this in English. Between 0 and pi over 2, as well as between pi and 3 pi over 2. Is that okay? It's above 0 between 0 and pi over 2. It's above 0 between 0 pi and 3 pi over 2. How would you write those, though, in interval notation? So f of x is greater than 0 at all points between 0 and pi over 2. All points between 0 and pi over 2, and all points between pi and 3 pi over 2, because they just want to know where on the x-axis it is. It's between these 2 points, and it's between these 2 points. It doesn't include them. We don't use brackets because at those points, it is not greater than 0, it's equal to 0. Y is equal to 0. And remember, f of x is just y. So y is greater than 0 at 0 to pi over 2, and again at pi to 3 pi over 2. Good. All right. And finally, we have a function without a graph, but as I said, you are welcome to graph it. They're going to ask us to find the domain. Is that point on the graph? And when y is 4, what is x? And does it intercept the x-axis? Good. All right, so we were talking about a graph before, but now we have an equation. All right. Find the domain of f. When we talked about the domain, what did we talk about? What can't we do? The domain, if it is a fraction, means that we cannot have 0 in the denominator. Okay? Do not allow 0 in the denominator. That is what we are limited to. Okay? What x value would cause us to divide by 0? Cause the denominator to be 0. Right? when we look at x plus 3 divided by x plus 4, are there any values of x that would make the denominator equal to 0? What you want to do is take the denominator and set it equal to 0. The denominator is x plus 4, set it equal to 0. Good. Subtract 4 from both sides. X equals -4. That means if I put -4 in right here, I would get 0 in my denominator, and that is outside the domain. Okay, that looks true, right? -4 plus 4 equals 0, so that's bad. So my domain is x such that x cannot be -4, which can also be written as -infinity to -4, -4 to infinity. Those are just two different ways to write the same thing for A, okay? For B, I would just encourage you to graph f of x on Desmos. All right, so just putting it into Desmos, putting the point into Desmos lets you decide whether it is on the line of the graph, or I should, if I have the equation x plus 3 over x plus 4 equals f of x or equals y, right? Then I can take that point and put it in here. If it's on the graph, that will be true. If it is not on the graph, that will be false, all right? 1 is my x, 3/4 is my y, right? So when x is 1, is y equal to 3/4? Is what they're asking, right? Let's substitute. I'm going to put 3/4 here. I'm going to put 1 here. So I replace my x's with 1s. I replace my y with 3/4. Is this true or is this false? 1 plus 3 is 4. 1 plus 4 is 5. 4/5 is equal to 3/4. That is not true. So we're going to say no. Right? The statement is no longer true. The equation is not true. So that point will not be on the line of that equation. C asks if f of x equals 4, what is x? And what point would that make it on the graph of f or f of x? So f of x equals 4 also means y is 4. Because remember, f of x is y. So for C, we're going to take that equation, x plus 3 over x plus 4, and it's saying all of that, or f of x equals 4. All right, there's going to be a point or a value for x in which x plus 3 divided by x plus 4 is equal to 4. Okay. Is that 4 an input? Let's just think about this. Is this an input or an output? That's an output, right? If it were an input, it would be in place of the x, but because it's in the place of the y, it's an output. If the output is 4, what is the input of x? Good. We have to solve it. Yeah. All right, how do we solve this? We're solving it for x. We have an x in the numerator and in the denominator. A fraction means division, and I have a 4 over here. If I want to get rid of the fraction, I'm going to multiply both sides by the denominator of the fraction. So I'm going to take that fraction, multiply it by x plus 4. Anything I do to that side, I have to do to the other side, okay? That means I have canceled this. On this side, I'm left with x plus 3. Here, I'm going to distribute that 4 to be 4x plus 16. Good. So now I have x plus 3 equals 4x plus 16. Now I want to just solve for x. You can move the 4x over here. You can move this x over here, whatever you would like to do. That becomes 3 is 3x plus 16 Move the 16 now. 3 minus 16 is 13. Good. And last step, divide by 3. So we have 13 thirds is equal to, oh, sorry, negative 13 thirds is equal to x. All right, you can now put into Desmos the point. All x and y's are at the points x, comma, y, right? So we have negative 13 thirds, comma, 4. You put that into Desmos and determine whether or not that is on the line of the graph. Okay. And wait, I can do it. All right. And last one, D. What are the coordinates of the x-intercept of the graph of f? All right. To find x-intercepts, remember that we just set y equal 0. When y is equal to 0, what is our x value? That will give you your x-intercept. Okay, so we have f of x is equal to x plus 3 over x plus 4. What's my y? My y is the f of x. So f of x becomes 0. 0 equals x plus 3 over x plus 4. Again, I want to get rid of my denominator. So I'm going to multiply everything by x plus 4. Anything I do to that side, I have to do to this side. X plus 4 times 0 is still just 0 because 0 times x is 0, 0 times 4 is 0. That cancels that. So x 0 equals x plus 3. Now we're solving for x. So subtract 3, x equals negative 3.